Interhalogen compounds, class 12 NCRT P block elements. When two different halogens react with each other, interhalogen compounds are formed. They can be assigned general composition of XX dash, XX3, XX5, XX7, where X is larger size, X dash is smaller size, and X is more electropositive than X dash. As the ratio between the radii of X and X dash increases, the number of atoms per molecule also increases. Thus, iodine heptafluoride is possible. Okay, now iodine 7 fluoride. Iodine heptafluoride is possible. Should have maximum number of atoms as the ratio of iodine radii between iodine and fluorine should be maximum. That is why formula of IF7 is possible. All that story you see here. These preparations are asking in even IIT advanced exam also. You can expect these. Cl2 plus F2, 437 kelvins CLF. If you are using excess, CLF3. Temperature slightly more. Here equal volumes, here it excess. Then I2Cl2, ICl, equal volumes, equimolars. Chlorine is excess, ICl3. Br2 plus 3F2, BrF3, diluted with water, or if you are using excess, BrF5. Direct, you need to remember this because no logic here. The logic you can apply here is, see, here some compounds are given. Should not be asked about this, but let us see. Okay, structures you can say. CLF, all these structures will be very simple. You can't say that this is linear because only one atom is there, but the structure will be like that. It's a CLF is colorless gas, BRF pale brown gas, IF detected spectroscopically. So which of the following detected spectroscopically? Didn't ask till now, but there is a possibility. BRCl is a gas, ruby red solid, brown red solid. Which of the following has two forms, alpha and beta forms, like that, block solid. All these CLF3 colorless gas, BRF3 yellow green liquid, IF3 yellow powder, orange solid. Okay, so not easy to remember. Don't worry, the structures you remember, that's all. And IF5, BRF5, CLF5 pentafluorides, IF5 colorless gas but solid below 77, colorless liquid. Structure same structure, square pyramidal because of one lone pair. It is colorless gas, pentagonal bipyramidal. So these points no one can remember. So don't worry about this. Better you go with the structures. Here one very interesting point will be there, that is hydrolysis. Before going to hydrolysis, what is mentioned here, you see. These are all covalent molecules and are diamagnetic in nature. First important point. They are all volatile solids or liquids at 298 Kelvin except CLF, which is a gas. Their physical properties are intermediate between those of constant halogens, except that their melting points and boiling points are little higher than expected. That means ClCl, BrBr, and you are thinking about ClBr, like that. So ClCl, BrBr, in between of these properties should be there. Their chemical reactions can be compared with the individual halogens. In general, interhalogen compounds are more reactive than halogens. Important point. Except fluorine. This is because XX bond in interhalogens is weaker than XX bond in halogens. Or you can say because of dipolar nature, because of electronegativity difference, it will be more reactive. Except FF bond. All these undergo hydrolysis, giving halide ion derived from the smaller halogen, and a hypohalate ion or halate or perhalate anion derived from the larger halogen. Okay, now I can give you some examples here. For example, CLF gives you HOCl and HF. Okay, now break here. CLF3 break here. Plus 3 oxidation state. So HClO3 plus HClO2, sorry, plus 3HF. Here 1 water, here 2 water. ClF5, for example, if it is there, 3H2, HClO3 plus HF. Don't think much. Here chlorine oxidation state plus 1. Same oxidation state acid is found. Okay, it is easy to remember. And IF7, very simple, 4 water molecules, HiO4 plus 7HF. Here plus 7, here also plus 7, like this. Structures are already we have discussed just now, so that is important. See here one compound is mentioned here, BrF3. You can say directly Br. F3 means there are 2 lone pairs and 3 bonds. So it is sp3d hybridization. 2 lone pairs are there. So this shape is slightly bent shape. Okay, bent T shape. The shape would that a slightly bent T-shape. Rest all we know very, very well in chemical bonding lesson. These compounds can be used as non-gas, non-aqueous solvents. Interhalogen compounds are very useful in fluorinating agents. ClF3, BlF3 are used in the production of UF6. You can see this reaction. Little interesting. ClF3 is turning into ClF. That's it for group 17 elements. About group 18, we'll meet soon. Thank you, guys.